So here's a walkthrough number 51 in section 3.3, and we're looking to maximize the area of this rectangle. Come up with the dimensions and maximize the area of this rectangle. So what I did is I created this GeoGebra applet, and what we can do is here's the situation. Here's the parabola that we're inscribing this rectangle in, and what we're trying to do is figure out which um, what triangle or what rectangle, I'm sorry, will maximize the area. And what I'm hoping you gain out the insights out of this when you're just dealing with a freestanding quadrilateral like this, a square, or as closest to a square as you can get, it's going to be the maximum area. So we know, I'm looking at this picture, it's going to be somewhere around that dimension. So what is the dimension, the area of that? That says 8.4 square units, if I did all the math right for that. But because this is, we want to verify it and make sure, we have to come up with the dimensions of this rectangle, or come up with an expression for the dimensions of the area, the dimensions of this rectangle, and then come up with a formula for the area. Okay, so back here I made a copy of this, and what you need to do with this is come up with the length and the width, and I tried to prompt you here, the writing. So I know this is x from here to here, and it's also the same distance over here because it's symmetric. It is a parabola. So the dimensions for this length is 2x. And then I want to do the dimensions of the height, and that changes if you go back and look at my sketch here. The y coordinate changes because you're taking that x value, whatever that x is, and dropping it into the parabola equation, uh, 5 minus x squared. So that's why I said here in this note that the y value at this point is 5 minus x squared. And that's what the height of this rectangle is. So then what we're trying to do is come up with an expression for the area. So the area depending on x is 2x. That's 2x. Make sure it's doing it right. So 2x times 5 minus x squared. And if we put this in standard form, that gives me a parabola, 10x minus 2x cubed. Actually, it's not a parabola, is it? And then we're going to graph that baby. So out of Desmo, I graphed it, and I'm seeing a cubic equation, and because a negative, and when x is negative, that doesn't make any sense in the context of this uh, situation. Well, I guess because you're dealing with the other side of the x-axis, but really we're concerned about this x, right? Because that we're just going to double it, and that'll give us the length of that side, right? So let's see, where am I? So I'm going to zoom in. I think I can, unless I changed my. I'm only really going to be concerned when x is greater than 0. And what I'm seeing from this cubic is it's maximizing. There's a local max right there. Okay, and that's at about 8.607. And at this point, we really can't use any other math to decide where the maximums exist. You'll learn in calculus how to take a derivative and use that, but that's not yet. Okay, so that's all I'm expecting you to do, is be able to develop the equation and then use a graph to figure out where the max and the min are, or depending if it's a minimizing problem. In this case, it's the maximizing. Okay, hope that helps.